In this video, we are still solving equation for chapter 7. Now number 15. A spherical ball has radius 2.4 centimeter. Shows that the volume of the ball is 57.9 correct to three significant figure. So volume, the formula for the volume is given to you. So use this formula. So the volume 4/3 by the radius 2.4, so 2.4 power 3. And the answer 57.90, so 57.9. So 57.9. For B, 6 spherical balls of radius 2.4 centimeter fit exactly into a closed box. The box is a cuboid. Find the length, width, and the height of the box. To find the length, this is the length, width, height. To find the length, we have 3 spheres adjacent to each other. Each sphere, its width like diameter, or 2 radii. So 2 radii. So how many radius do we have? 6 radii. So to find the length, r multiplied by 6. R is 2.4. So 2.4 multiplied by 6. 2.4 multiplied by 6 equal 14.4. So the length 14.4. So the length 14.4. The same for width. We have 2 spheres together adjacent to each other. So 2 radii for the first one and 2 radii for the second. So we have 4 radii, so 4 radius. So to find the width, the radius 2.4 multiplied by 4. So 2.4 times 4, 9.6. But for the height, we have the height of the cuboid is the same like the height of the circle, which is 2r or diameter. So the height will be 2.4 times 2, which is 4.8. So 4.8. Now for double I, to find the volume of the box, the volume of cuboid, length by width by height. So 14.4 times 9.6 times 4.8. So the answer 663.552 centimeter cube. For triple I, the volume of the box not occupied by the balls. The volume of the box not occupied by the balls. So we need to find the volume of the box minus the volume of the 6 balls to find the volume of the box not occupied by the ball. So volume of box minus volume of balls. Volume of box, we have the volume of box. So 663.552 minus the volume of one ball, 57.9. So 57.9 multiplied by 6 because we have 6 balls. So the volume of the box minus the volume of the 6 balls to find the volume of not occupied by the balls. Find the volume of the space inside the cuboid. The answer 316.152. For IV, the surface area of the box, this box is closed. So the surface area for a cuboid equal 2 length width plus 2 width height plus 2 length height. So equals to 14.4 times 9.6 plus 2 times 9.6 times 4.8 plus 2 times length times height 14.4 times 4.8. The answer 506.88. 506.88. See, the 6 balls can also fit exactly into a closed cylindrical container as shown in the diagram. Find the volume of cylindrical container. To find the volume of the cylinder by r square times height. By r square times height. So r is the same. Radius of the cylinder is the same like radius of the sphere. So r is 2.4 centimeter. What about the height? For the height we have 6 spheres together. So, and each circle its height like diameter or 2 radii. So r times 12. So 2.4 times 12, we can find the answer. So the height 28.8. Now the volume by times 2.4 squared times 28.8. The answer 521.2. 521.2 to 1 decimal place. Next, the volume of the cylindrical container not occupied by the balls. So I need the volume of the space also. To find the volume of the space, volume of the cylinder minus the volume of the 6 balls. So 521.2 minus 57.9 multiplied by 6 balls minus the 6 balls. The answer 173.8 centimeter cube. Now for triple I, surface area of the cylindrical container. To find the surface area of the cylinder, we have rule. Surface area equal 2 by RH, this is the curved surface, plus 2 by R square, because we have circle at the top and circle at the bottom, because this is a closed cylinder. So 2 by RH plus 2 by R square. So 2 times by times R, which is 2.4, times the height, which is 28.8, plus 2 by times 2.4 squared. The answer 470.48. For number 16, before we start number 16, because this related to similarity also, so we need to explain what is the meaning of similarity. If we have two shapes, we call the two shapes are similar. For example, if we have two triangles, we call the two triangles are similar if they have the same shape but different side. Same shape but different side. For example, if this side 5 and this side 15, this side 4 and this side 12, this side 7 and this side 21. The two triangles are similar. One of them is enlargement for the other. So for example, this side 5 and this 15 multiplied by 3, and 4 multiplied by 3 equal 12, and 7 multiplied by 3 equals 21. So we call that the two triangles are similar. And if we have two triangles are similar, we can deduce that the corresponding angles are equal. This angle equals this one, this angle equals this one, and this angle equals its corresponding. So the corresponding angles are equal and the sides are proportional. Proportional means what? Means the ratio between this side to that one is the same like between the ratio between this side and that one. The ratio between this side and the corresponding one. So the ratio between 5 15, 1 to 3, 4 to 12, 1 to 3, 7 to 21, 1 to 3. So the two triangles are similar if the angles are equal, and if they are similar, we can deduce that the sides are proportional. The sides are proportional. The sides are proportional. Okay, this is the meaning of two triangles are similar. Now we can start number 16. The diagram shows a plastic cup in the shape of a cone with the end removed, so cone but without the end. The vertical height of the cone 20, the height of the cup 8, the base of the cup has radius 2.7, shows that the radius of the circular top of the cup is 4.5. We need to prove that R is 2.5. Do we have similar triangles in this shape? Or can we use similarity to prove that R is 2.7? If we draw the height for the cone, now we have two triangles. I'll shade one of them. So we can shade this one. The small triangle and the bigger one are similar. Why similar? Because the angles are equal. This angle included in both triangles, the smaller one and the bigger one. And this angle, if we join this one, this angle equals that one, corresponding and equal. And also this angle, which is 90, equals this one. So the angles are equal. So the small triangle and the bigger one are similar. Why similar? Because the angles are equal. This angle equals this one corresponding, and this 90 and this also 90, corresponding angles, and this common angle between the smaller one and the bigger one. So the triangle are similar. If the triangle, the small one and the bigger one are similar, so the sides are proportional. So the same ratio between the sides. So we can say that radius, this side for the small triangle, the ratio between this radius and that one, 2.7 to R, the ratio between 2.7 to R is the same like the ratio between the height of the small triangle and the height of the bigger one. The height of the small triangle, we can find this height by subtracting 8 from 20. So 20 minus 8 equals 12. So the height of the small triangle equals 12. And the height of the bigger one, 20. So 12 over 20. So because the two triangles are similar, so the sides are proportional. So this side over that one equals this height over this one. Now we can find R with cross multiply. So R equal 2.7 times 20 divided by 12, which is 4.5 centimeter. Double I, calculate the volume of the water in the cup when it is full. And it's given to you the volume of the cone 1 over 3 by R squared times height. So to find the volume of the water in the cup, you can find the volume of the cone, the big cone, minus the volume of the small cone. To find the volume of the cup, volume of the big cone minus the volume of the small cone. So volume of the cone by R squared times height. So I'll solve double I here. So volume of the cone for 1 over 3 by r square times height. So for the big cone, 4.5 square times the height, which is 20, minus the volume of the small cone, 1 over 3 by times 2.7 square times the height, which is 12. Then we can find the answer. So the answer 332.5. 332.5 centimeter cube. Now for BI, show that the slant height of the cup, this is the slant height of the cup, S, equal 8.2. How to find the slant height of the cup? In the cone, we have a relation between R and the height and the slant height. Okay? So the slant height is the hypotenuse for this right angle triangle. So we can find the slant height for the big cone, and also we can find the slant height for the small cone. So for the big cone, the slant height for the big cone, the slant height for the big cone equals square root 4.5 square plus 20 square, because we have right angle triangle, this 20 and this 4.5, so we can find the slant height of the big cone using Pythagoras theorem. The answer equal 20.5. And also by the same way you can find the slant height for the small cone, equal square root 2.7 square plus 12 square. So 2.7 square plus 12 square from Pythagoras theorem equal 12.3. Now to find the slant height of the cup, subtract 20.5 minus 12.3, so 8.2 centimeter. Now for double I, calculate the curved surface area of the outside of the cup. So to find the curved surface area of the outside of the cup, we don't have special rule for the cup, so we can find the curved surface area for the big cone minus the curved surface area for the small cone, then we get the curved surface area for the cup. So to find the curved surface area of the cup, find the curved surface area for the cone minus for the big cone minus the curved surface area for the small cone, then you get the answer. The curved surface area is by RL. So we need to find by RL for the big cone minus by RL for the small cone. So by times 4.5 times the slant height, which is 20.5, this by RL for the big cone, minus by R, by times 2.7, times the slant height for the small cone, which is 12.3, then we find the answer. The answer 185.47, or we can find can write 185.5. So 185.5 centimeter square. Number 17. Before we solve number 17, you should know this rule. The rate of flow equals volume over time. Rate of flow, volume over time. We can use triangle to write this rule. So this is rate R equal volume over time. So if I need rate, volume over time. If I need time, volume over rate. If I need the volume, rate into time. Now for number 17, a rectangular tank measures 1.5 meter, 0.8 meter, 0.5 meter. Water flows from the full tank into a cylinder at a rate 0.3 meter cube per minute. This is the rate. Calculate the time it takes for the full tank to empty. The full tank to empty. So to find the time, volume of the tank divide the rate of flow. Volume over rate to find the time. Volume over rate to find the time. So now we need to find the volume because we have the rate. We have the rate 0.3 meter cube per minute. So we need to find the volume. Volume of a rectangular tank is length by width by height. So 1.2 times 0.8 times 0.5 equal 1.2 times 0.8 times 0.5 equal 0.48 meter cubed. So to find the rate, to find the time now, a volume over rate, so 0.48 over the rate, which is 0.3. Now we get the time in minute. So 0.48 divided by 0.3 equal 1.6. 1.6. This 1.6 means 1.6 minute. If I need the answer in minute and second, so just press this button like that, to convert to minute and second. So now we have 1 minute and 36 seconds. 1 minute and 36 seconds. So 1 minute and 36 seconds. Now for B, the radius of the cylinder 0.4 meter. Calculate the depth of the water when all the water from the rectangular tank is in the cylinder. So now the volume of the water of the cylinder 0 is the same like the volume of the water of the tank, so 0.48 meter cube. This is the volume of the water inside the cylinder. But we know that the volume of the water inside the cylinder is pi times r square, which is 0.4 square, times the depth. So by r square times height, or the depth. So we can find the depth now. 0.48 divide by into 0.4 square. The answer is 0.95523 significant figure meter. Now for C, the cylinder has a height 1.2 meter and is open at the top. The inside surface is painted at a cost $2.30 per meter square. Calculate the cost of the painting the inside surface. So to find the cost, we need to find the surface, the inside surface. To find the inside surface, because it's open from the top, so we need to find the area of the base, which is the area of this circle, plus the lateral area, or the curved area. For the cylinder, the curved area by R, 2 by RH. This is the curved surface area, or the lateral area for the cylinder, 2 by RH. The total surface area in general for the cylinder, total surface area, 2 by RH, this is the lateral area, or the curved area, plus 2 by R square if you have two bases. But if it's open from the top, so we have one base. So 1 by R square or by R square. So this is the total surface area if it is open from the top. 2 by RH plus 1 by R square because it's open from the top. So now we have R and we have H. So 2 pi into R, which is 0.4, times the height, which is 1.2, plus pi times 0.4 square. After you find the surface area, you have to multiply by 2.30 to find the cost. So the surface area equal 3.5223 significant figure meter square. To find the cost, multiply this area by 2.30. So multiply by 2.30. So the answer about 8.1023 significant figure. Number 18. The diagram shows a cone of radius 5 cm and slant height 13. Calculate the curved surface area of the cone. The curved surface area of the cone, we have rule by RL. By RL. L is the slant height. R is the radius, and we okay. So we can find the curved surface area directly by times R times the slant height, which is 13. So the answer 204.2. 204.2. 204.2 centimeters square. Now calculate the perpendicular height of the cone. To find the perpendicular height, we can use this triangle, this right angle triangle. From Pythagoras, we can find the height. So the height equal square root the hypotenuse square minus this side square. So 13 square minus 5 square equals 12. So 12 centimeters. So this is the perpendicular height. Now calculate the volume of the cone. The volume of the cone 1 over 3 by r square times height. So 1 over 3 by r square, so 5 square, times the height. This is the perpendicular height, which is 12. So answer 314.16 to 2 decimal places. 314.16. Now write your answer to part A triple I in cubic meters. So this is answer 314.16 cubic centimeter. So to convert to cubic meter, from cubic centimeter to cubic meter, divide by 100 cube or divide by 1 million. So divide the answer by 100 power 3 so the answer 0.000314. Then 16. Now for B, this is very important, this part. The cone is now cut along a slant height and it opens out to make the sector AOB. So we cut the cone to get the sector. So the slant height of the cone will be the radius of the sector. So the radius of the sector will be 13 centimeter. So if we cut cone and we get sector, so the slant height of the cone will be the radius of the sector. Slant height of the cone will be the radius of the sector. And this circle will be this arc. So the circumference of this circle equals the length of this arc. Circumference of the circle equal length of arc. Okay? So circumference of the circle 2 by r. So 2 times pi times 5. The length of the arc, we have a formula for the length of the arc in a sector, which is theta over 360 is the length of the arc, times 2 by r, but r now 13, not 5. So the circumference of the circle equals the length of the arc. Circumference of the circle equal length of the arc. Circumference 2 by r, and r is 5, so 2 pi times 5. Length of the arc, angle over 360 times the circumference, or times 2 by r, but now r 13. So now, because they are equal, so we can equate them. So 2 pi times 5 equal theta over 360 times 2 pi times 13. You can cancel 2 pi with 2 pi to find theta. Now make theta is the subject. So theta equal 5 multiply 360, because 360 transpose 360 to the other side by multiply, and 13 go divide. Then you can find theta 138.46, so 138.5 to nearest 1 decimal. Number 19, a sector of a circle has radius 12 centimeter and angle 135. Calculate the length of the arc of his sector. I need the length of the arc. The length of the arc is same 135 the angle over 360 times 2 by r times 2 by 12 times 12. So we can find the length of the arc 28.3 to 3 significant figure. Now double I, the sector is used to make a cone. Calculate the base radius r. So to find r, we use the sector to make a cone. So the length of the sector, the same, equals the circumference of the base of the cone. So the length of the arc, which is 28.3, equal the circumference of the circle of the base, 2 by r. So 2 by r equals 28.3. So we can find r. 28.3 divided by 2 pi. So the answer 4.50. So 4.5 centimeter. Now calculate the height of the cone. The height of the cone, we have the radius and we have the slant height. We can find the perpendicular height now. So h equal, from Pythagoras, square root 12 square minus 4.5 square. So 11.1 centimeter. Now for B, the diagram shows a plant pot. It's made by removing a small cone from a larger cone and adding a circular base. So what we need, this is the cross section of the plant pot. Radius 15, here radius 8, and the slant height for the plant pot is 35, and the slant height for the larger cone is L. Find L. We need to find L. Okay, so to find L, we have the radius 15. If we can find the perpendicular height, then we can get L. So we have two triangles similar, this one and the bigger one. 8 divided by 15 equal this length, the hypotenuse of the smaller triangle, over the hypotenuse for the larger one. This one is L, and this 35, so this side is L minus 35. So we can say that this L minus 35. So from similarity, we can say that 8 over 15, 8 over 15 equals this side over the whole one. So equal L minus 35 over L. Now cross multiply to find L. So 15 times L equal 15L. 15 times 35, 525. 525. And the 8 times L equal 8L. Now 8L transpose 8L to the other side by negative. So 15 minus 8 equals 7. So 7L equal, and transpose negative 525 to the other side by positive. 525. So L equal 525 divided by 7 equal 75. L equal 75. Now for double I, calculate the total surface area of the outside of the plant pot. To find the total surface area of the outside of the plant pot, we cannot find directly, but we can find the curved surface area of the larger cone minus the curved surface area of the larger cone to get the curved surface area of the plant pot. And then we have to add the area of the base of the plant pot, this circle. So we need to find the total surface area. We need the total, the curved surface area for the larger cone. So by R times 15 times the slant height for the larger cone, which is 75. So this pi RL for the larger cone minus pi RL for L minus 35, the slant height for the small cone. So 75 minus 35 will be 40. So by times 8 times 40. So now we find the curved surface area for the larger cone minus the curved surface area for the small cone. Then we get the curved surface area for the plant pot. We have to add the area of this base. We need to find the area for this base. This circle with radius 8 centimeter. So by into 8 square by R square. The answer equal 2730. 2730 centimeter square. Now for C, some cones are mathematically similar. For these cones, the mass M is proportional to the cube of the base radius R. So M is proportional to cube of R. So we can say that M equal constant times R cube, because M is proportional to the cube of R. One of the cones has mass, so M equal 1458 and radius 4.5. Then you can find K. So to find K, M 1458 equal K into 4.5 power 3. So to find K, divide 151458 divide by 4.5 cube, so 16. So M equal 16 R power 3. 16 R power 3. Two of the cones have radii in the ratio 2 to 3. Write down the ratio between their masses. So this also related to the similarity. If we have two similar shapes or two similar solids, the ratio between their masses M1 to M2 like the ratio between volume like V1 to V2. So the ratio between volume and volume also like side 1 power 3 to side 2 power 3. So the ratio to mass the ratio of mass is the same like ratio between volumes, and the ratio between volume to volume is cube the ratio between side to side. So the ratio between the two sides is 2 to 3, so cube both, so 2 power 3 to 3 power 3, so 8 over 27.